Good evening, dear students. First give reply. This audio, video, everything clear na? Please give reply. Okay, very good, very good, very good, very good. In this session, let us discuss some questions correspond to this network analysis. Okay, shall we start? I hope everything clear now. This video, audio, everything clear, I think. Okay, 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 dear students. Okay, for every question, I want response from your side. That is next question. Note on this one. Now let's check it out. Let's check it out. Now for this example, now first if you apply KCL at this point, in the data itself given, whatever this Ix is the outgoing current. Now corresponds example, whatever this Ix is the outgoing current. Whatever this 5 amperes also outgoing current, 2 amperes also outgoing current. It is outgoing current, it is also outgoing current, it is Ix also outgoing current. Whatever KCL says, sum of incoming current should be equal to sum of outgoing currents. Sum of incoming currents should be equal to sum of outgoing currents. Then here outgoing current, how much here? 5 plus 2, 7. Whatever this one is the Ix. Now we can write this with a 7 plus Ix. 7 plus Ix. Now for this example, wherever the current is entering, take that one as a positive and other one is a negative. Then here for this example, now for this dotted lines, correspond dotted lines can write with respect to KVL equation. Correspond to dotted lines can write with respect to this KVL equation. Again, whenever we are writing the KVL equation, indicate the respect to polarities. Wherever the current is entering, there is a positive and other one is a negative. Now correspond this one, Ix is entering here. Wherever the current is entering, there is a positive, other one is a negative. Then for this dotted lines, can write the respect to KVL equation. Check karo. If you write the respect to KVL equation, let us start from here. Higher potential to lower potential voltage drop. What resistance value is the 2. How much current circulating is the Ix? How much current circulating in the Ix? 2 Ix. Now again here higher potential to lower potential voltage drop. Ix by 2. Again here also higher potential to lower potential. Voltage drop. Now how much current circulating is 7 plus Ix. How much current circulating? 7 plus Ix. But the respect to resistance is 3 ohms. Respect to resistance 3 ohms. Now can you equate this entire expression to 0? Actually, if you look the figure, very complex network is given. Only with help of the KCL and KVL, directly we are concluding the answer. What is the unknown in this expression? Only Ix. Now I gave all the hints. I want answer from your side. Simplified, find out Ix value. Very good, very good, very good, very good. Many students are giving reply. Check karo. I am writing your answers only. Check karo. Now many students are saying minus 3.81. Is it correct? Others? I will let the steps only. For every question you have to give the answer. Calculation part आप करना है. I want response from side. 3.81. Very good, very good, very good. Minus 3.81. Very good, very good, very good. Give the responses. Give the responses. Everyone has to do the calculations. Very good, very good, very good, very good, very good, very good. Okay. In the objective questions point of view, first we have to think what is the easy way to conclude the answer. After thinking only, go for the respective method. Okay. All these questions are useful for the electronics, electrical instrumentation. Okay. Okay. Very good. Very good. Very good. Very good. Now write this question. Question copy कर लीजिए. Okay. Now observe here. Now here we can solve this problem in the different approaches. We can solve this problem in different approaches. Just I'll give the hints. We can solve this problem. One of the method for this one is we can use a star delta transformation. That is one method. Later you can verify by using star delta transformation. But here I am not going for star delta transformation. Let us see one more easy method. One more easy method for this one. In this particular example, इधर देखिए. This AB points present along the y-axis. AB point present along the y-axis. Now in this example here, this dotted line is indicated. Dotted line indicated along the x-axis. The angle between the AB and this dotted line is exactly 90 degrees. 90 degrees means we can use word as a perpendicular. 90 degrees means we can use word as a perpendicular. Now if you observe carefully with respect to dotted lines, this upper section and lower section both are exactly identical. This 12 we can separate as a 6 and the 6. The 6 we can separate 3 ohms and the 3 ohms. With respect to dotted lines, this upper section and lower section both are exactly identical. Identical means we can use word as a symmetry. We can use word as symmetry. That means in this example, with help of the perpendicular symmetry, let us solve the problem. Later you can verify answer by using star delta transformation also. Okay. Now according to this perpendicular symmetry, whenever the dotted line is indicated, if any joints are present, the corresponding joint is named as a equipotential point. The corresponding point is named the equipotential point. Now in this example, according to perpendicular symmetry, now this equipotential point can be disconnected along the dotted lines. According to this method here, this equipotential point is disconnected along the dotted lines. In this example, where the dotted lines are indicated along the x-axis, it should be disconnected along the dotted lines. If you disconnect this one, the same figure, in this one we are going for the perpendicular symmetry concept. Now this joint is disconnected. Now can you write the corresponding resistances? 12. Now this equipotential point is disconnected. Now we can simplify the calculations. देखिए इधर. Now how this 12 and 12 both are connected in the series. It is connected series. The series combination is connected. The series combination connected in parallel to this 12 ohms. Similarly here, how the 6 and 6 both are connected? Series. The series combination is connected parallel to 6 ohms. Can you simplify it? Simplify karo ji. Simplify karo. If you simplify this one, check it out, we can write like this. Check it out, can you write like this? Now corresponds example, for this entire parallel combination the 8 ohms, for this parallel combination the 4 ohms. Finally, what is the requirement? Equivalent resistance with respect to A and the B. Our requirement is the equivalent resistance with respect to A and the B. Equivalent resistance with respect to A and B. Now we can easily conclude. What is the total resistance of this branch? This branch resistance is the 8 ohms. What if this branch is also 8 ohms? Now finally 8 ohms both are in the parallel. What about this equivalent resistance is the 4 ohms. Okay. Here I conclude the answer by using perpendicular symmetry. Later hona bole to you can verify the answer by using star delta transformation. Okay. Four ohms. Somebody got 2.67. चेक करो जी एक बार. 2.67 कैसे आ गया? चेक करो एक बार. Very good. Somebody got 2.67 कैसे आ गया? कौन सा मेथड लगाया? Okay. Very good. Mohammed, very good. Rahul Kumar. Good, very good. Okay. बाद में verify the answer by using star data transformation. Check करो. In that manner also get the same answer. But this is an easy approach. To conclude the answer. Especially if you observe the previous papers of the GATE. For this type of the equivalent resistance problems, by using either perpendicular symmetry or parallel symmetry concept, you can easily conclude the answers. Okay. Now note on this question. Note on this question. Very good. सोचिए, what is the easy way to conclude the answer? Whenever you are solving any problem, first 5 seconds, first think what is the easy way to conclude the answer. Check karo. I'll give the hint. Let us give the names as this sum A, B, C and the D. Give the names as A, B, C and D. Just observe here. In this one total how many branches are there? देखिए इधर branch 1, branch 2, branch 3, branch 4, branch 5, branch 6. Remember as whenever the 6 branches are there, by rearranging this one, we can redraw this one as a bridge. Whenever the 6 branches are there, we can redraw this one as a bridge. check karo ji. If I give the names like this A B C D, A B C D, check karo, cannot like this. Every time remember as a, whenever the 6 branches are there, try to redraw that figure as a bridge. Corresponding bridge, how many branches are there? 1, 2, 3 and the 4. And the 2 diagonal points. This is the one diagonal point, 5th one. Now this is the other diagonal point, 6th one. Given network, we can indicate like this. Given network, we can indicate like this. Okay? Now why we are developing this one as a bridge? Now let us check it out whether it is satisfying the balance bridge condition or not. For this example, to make calculation simple, first let us see whether it is satisfying the balance bridge condition or not. Now for this balance bridge, what is the condition? Product of opposite arms should be equal. This product of opposite arms. Product of opposite arms should be equal. Now satisfying or not satisfying? 6 and the 4. Again the 6 and the 4. Now product of opposite arms are equal. Balance bridge condition is satisfying. Whenever the balance bridge condition is satisfying, then what is the current flowing through diagonal points element equal to 0? The current flowing through this diagonal points element equal to 0. Now correspond this branch, we can say current of this one equal to 0. That means the current flowing from A to C. The current flowing from the A to C is become the 0. Whenever the current equal 0, we can solve the problem again the different approaches. One of the easy approach is the current 0. Current 0 means we can indicate this one as an open circuit. Current 0 means we can indicate this one as an open circuit. We can indicate as an open circuit. 4 ohms, 6 and 6. Whatever this one is a 200 milliohms. What is the requirement? Power dissipation. Power dissipation corresponds to 200 milliohms. When it is open circuited, can you find out equivalent resistance? How this 4 and 4 both are connected in the series? 8. What about this one? How the 6 and 6 both are connected in the series? Now here the how these 8 ohms and 12 ohms, 8 and 12 both are connected in the parallel. Can you find out the equivalent resistance? Can you find out the equivalent resistance? Check karo ji. What about this one? The 200 milliohms. Anybody for this one can find out equivalent resistance for parallel combination? Anybody answer? Many students give the answers also. Power dissipation. Very good, very good, very good. I appreciate. Check it out. These are 4.8 ohms. Now can you find out the total equivalent resistance now? Total equivalent resistance 4.8. Whatever this one is a 200 milliohms. 200 milliohms. If you simplify this one, what is the total equivalent resistance? Is 5. If you simplify this one, what is the total equivalent resistance? Is 5. Total equivalent resistance is 5. Now can you find out the current of the source? Can you find out the current delivered by the source? Ten by 5 equal to what current is 2 amperes. Current is 2 amperes. Now what is the requirement? In the question is asking the power dissipation correspond to 200 milliohms. Power dissipation correspond to 200 milliohms. Simply can reduce with the I square R. What the current of this one is 2 amperes. Our requirement is power correspond to 200 milliohms. 200 milliohms. What is the answer? Now many students are saying answer. Very good, very good. 0.8 watts. 0.8 watts. 0.8 watts. Very good, very good, very good. I appreciate. Very good, dear students. Very good. Very good, very good, very good. That is question. Is it visible now, picture? Nitish Mishra, is it clear now? Okay, let's check it out. In this example, here I am going for nodal analysis. We can apply our mesh analysis or nodal analysis, choice is ours. But if you go to the mesh analysis, more number of equations are present. If you go for mesh analysis, we have to apply the super mesh concept, because current source branch is common for the mesh 1 and the mesh 2. Instead of that one, if you go for node analysis, correspond node, only one equation is only obtained. One equation only obtained. Now with respect to ground potential, what is the polarity of this one is a plus. With respect to this ground potential, what is the polarity is a plus. Now let us write the respective equation. Whenever you are writing equation for the node, assumption is the node voltage is greater when compared to all other voltages. With that assumption, write the equation. Now in this example here, plus plus, similar polarities subtraction. By KCL, we can write say VA minus 120. But with respect to resistance is the 4. Outgoing current. Now whatever this one is, in this one two sources are there. One is a dependent source, other one is a independent source. Now focus on the polarities carefully. Now plus plus, similar polarities subtraction. VA minus 10I1. Again the plus plus, similar polarities subtraction, minus 40. But respect to resistance equal to 8 ohms. Resistance equal to 8 ohms. Outgoing current. Now whatever the 12 amperes is the incoming current. This 12 amperes is the incoming current. Now we got the equation 1. Now come to one more unknown. In this one, how many unknowns are there? One is the VA. What about other one is the I1? Let us see what is the I1 equation here. Let us see what is that I1 equation. Now in this example here, the current how the I1 direction given is upwards. Plus plus, similar polarities subtraction. We can write 120 minus VA. But the corresponding resistance is the 4 ohms. Now in the question, what is asking is the I1 value. What is our requirement is the I1 value. Now I give the two equations. With help of these two equations, can you find out I1 value? With help of these two equations, can you find out I1 value? Do it. I give all the hints. You can solve any method. Shuklaji, you can solve any method. Any method you can apply. Yes. Yes. Rahul Kumar, yes, we can solve like that also. You can apply any method. Anybody I1 value? Minus 7.27. Is it correct? Checked out. Many students are saying like this. Minus 7 point or 0.27. What are the answers? Different answers they are saying. Check karo ji. Verify the answers. Somebody is saying minus 7.27. Which one is the correct answer? Minus 0.27 or 7.7? What is the correct answer? Okay. Very good. Minus 0.727. Okay. Very good. Okay. Now this is very easy question. Can you identify which one is the appropriate option? Yes, very good, very good, very good, very good. Simple question. Yes, minus 5. Minus 5. Upper one is a minus 5. This is a minus 5 volts. This is a minus 5, is a plus 5. Minus 5, this one. It's very easy question. Very good, very good, very good, very good. Now in this one you can easily conclude. Now for these two elements, here the plus minus means addition. Plus minus means addition. What you write is for the 5 plus. But what is the voltage given as a minus 5? Voltage given as a minus 5. Then what is the net voltage? This one is how much here? 0. Net voltage 0. Whenever this net voltage 0, electrical equivalent circuit, how do you indicate this one as a short circuit? Net voltage this branch is 0. Then how do you indicate this one as a short circuit? Now carefully observe how the short circuit, this 10 ohms and 10 ohms. 10 ohms short circuit. How these three branches are connected in the parallel. When these three branches are in the parallel, what about this equivalent resistance? Equivalent to these three branches equal to 0. Equivalent 3 branches equal to 0. Now come to this branch. Now when the two current sources, when the two ideal current sources are connected in series. Now when the two ideal current sources are connected in series. When the two ideal current sources are connected in series, what is the equivalent value of this one equal to? I1 equal to I2. I1 equal to I2. Can you apply that logic here? Now, what about these three branches are replaced by short circuit, but remaining resistance is the 12 ohms. Remaining resistance is the 12 ohms. Now, these two current sources are replaced by a single equivalent current source. But a single equivalent current source is the 4 amperes. Simply we are applying this logic. Now, what is the one more resistance is the 4 ohms. One more resistance is the 4 ohms. One more resistance is the 4 ohms. Then here for this one, if you simplify further, how this 12 and 4 corresponds example, how this 12 and 4 both are connected in the parallel. Parallel means what is the equivalent resistance is the 3 ohms. Equivalent resistance 3 ohms. But the current of this one equal to 4 amperes. Current is the 4 amperes. Which one supporting here? D. Okay. Come to next one. Write this question. Write this question. Now let's check it out. Now for this one, you have to read the question carefully. What is asking is a energy absorbed. Energy absorbed. Now at the energy absorbed means we should include the energy correspond resistor and energy correspond capacitor. Both we have to include. In the same example, they may ask you to find out energy stored by the circuit. Energy stored by circuit means we should focus on the only energy storage elements. Energy storage element means we should consider only on the capacitor. But in this particular example, what is as the energy, total energy absorbed? That means we should include the respect to heat energy as well as the energy correspond capacitor. Both energy should be included. For this model of questions, read the question carefully. What is asking? Whether energy stored or total energy absorbed by circuit. Energy stored means we focus only on the capacitor. But what is the requirement? Absorbed. We should include both resistor and the capacitor. In this example, how the both elements are connected parallel. That means here the voltage across resistor and voltage across capacitor both are the same. In the question itself, the voltage waveform is given. Now he is asking the energy correspond to up to what point here? Up to 4 seconds. Now first let us see the 0 to 2 seconds interval. For 0 to 2 seconds interval, can you develop the equation here? How the waveform increasing the linearly? Now correspond to 2 seconds. What do you write this for the 2, 6. Now for 0 to 2 seconds interval, for 0 to 2 seconds interval, simply can use a y equal to mx formula. Directly I am writing here. Along the y-axis, what we included here in this example is a voltage. Now what about the slope is a y2 minus y1 by x2 minus x1. Directly I am writing here. If you find out the slope for this data, now what is slope is a 3. Along the x-axis, what do we celebrate the time? Now v equal to 3t. Now the general equation correspond to 0 to 2 seconds interval. Then what about for this one is a 2 to 4 seconds interval? It is a constant. 2 to 4 seconds interval, it is a constant. Now what is the requirement? Our requirement is the energy up to what point here? Up to 4 seconds. Here the total energy equal to, we should include the energy correspond resistor and energy correspond capacitor. Now correspond resistor, we can divide this one 2 intervals. Simply we can write general equation as a integral of p dt. 0 to 2 seconds and 2 to 4 seconds, integral of p dt. Now some of these two indicate the energy correspond to resistor. Now what about this one is a correspond capacitor? Directly you can write the formula is a half CV square. Directly you can write this with a half CV square. Half CV square. Now if you substitute the respective expressions, now energy equal to 0 to 2 seconds, simply you can write the formula is a v square by r dt. 2 to 4 seconds, v square by r dt, and the half CV square. Now can you substitute all the respective values in this one? Can you substitute respective values in this energy equation? Now total energy equal to 0 to 2 seconds interval. What general equation? V equal to 3t. This V replaced by 3t. What resistance value given as a 1. Now 2 to 4 seconds interval. Its magnitude is a constant. But constant voltage how much here? 6. Constant voltage is 6. Now in the data itself capacitance value is given. But given capacitance value how much here? Capacitance value is a 200. Now what about this voltage of this one is a final voltage is 6 volts. Now I gave all the hints. Can you simplify it? Simplify this one. Find out the energy. Find the total energy. I gave all the hints. Find out the total energy. What is the answer? 132 joules. Answers 132. 132 joules. Joules. Very good, very good. Very good. Okay. 132 joules. Write this one. In the previous question, if there is energy stored in the circuit, what the answer for that one is 36. The previous question. Okay. Okay. Now let us solve. In this example, what is asking as a corresponding given example is asking the input impedance. Input impedance at what instant? When the source current is in favor of the source voltage. Source current in favor of the source voltage. Source current in favor of the source voltage. It is possible only correspond which condition? Resonance. Now at resonance condition only that voltage and current both are the in phase. Okay, that is the one point. And one more thing, under resonance condition, how the circuit behaves as a resistive circuit. Now resistive circuit means we can conclude as a imaginary part of the equivalent impedance equal 0. Imaginary part of the equivalent impedance equal 0. Imaginary part of the equivalent impedance equal 0. Now with help of that concept, can you solve the problem? Now correspond this one inductive reactance. Inductive reactance, let us name this as JXL. Now for this one capacitive reactance. Capacitive reactance, let us name this as minus JXC. And corresponding resistor is R. Corresponding resistor is R. Then here for this example, can you find out respect to equivalent impedance? Can you find out respect to equivalent impedance? Now if you find out the equivalent impedance for this one, how the capacitor resistor both are connected in the parallel. Can we read this? Capacitor resistor both are in the parallel. That parallel combination. This parallel combination connected series to inductor. The parallel combination connected series to inductor. In this one, what is the requirement? Now correspond resonance condition. Only real part is the present. Imaginary part equal 0. Imaginary part equal 0. Then in this first term, we can conclude directly it is imaginary part only. In the second term, can you separate the real and imaginary? Can you multiply the conjugate of this one? To separate real and imaginary, can you multiply the conjugate of this one? Can you multiply the conjugate of this one? If you multiply these two, can you separate real part of this one? In this one, can you separate the real part? Check karo ji. If you separate the real part, directly I am writing here. This is the imaginary part directly concluded. If you multiply these two, what is the imaginary part? What do you get? What is the real part? Real part of this is R XC square. Can we write this? Only real part I am indicating. Multiply these two terms. From that one separate real part. Real part check karo ji. XC J square minus becomes a plus. Now this is the real part. What the denominator we are using A minus B, A plus B formula. Now we got all the hints. In the question, what is asking as a current value indirectly at resonance condition, is asking the equivalent impedance at resonance condition. Equivalent impedance at resonance condition. Now, or what is XC means, we can write as 1 by omega C. 1 by omega C. Now, I give all the hints. But resistance value how much here? 50 ohms. In the data itself given, whatever is omega equal to 100, omega equal to 100. Whatever the capacitor value equal to 50 microfarad, 50 microfarad. Can you substitute all the values? R equal to 50 ohms, but the omega equal to 100, capacitor is a 50 microfarad. Substitute all the respective values, you will get the answer. Anybody answers? At resonance condition, imaginary part of the impedance equal 0. Thereby only real part is the present. From that one you are concluding answer. Only real part is the present. Only real part is the present. Substitute respect to R value, omega value, C value. Check karo. Check karo. Many students are saying answer is the 47. Is it correct? Check karo ji. I am writing your answers only. Is it correct? Okay. Very good. Read this question. Now let's check it out. Now corresponds example in the case 1. Correspond to this example here, this case 1. For this data in this case 1, this capacitor and resistor both are connected to the parallel. Corresponds example, this capacitor is connected in parallel to the resistance, in parallel to the resistance, in parallel to the resistance. In the data itself given, now correspond case 1, what is the voltage, how much here? 300 volts. What with respect to frequency of this one is a 50, respect to frequency is a 50 Hz. Respect to frequency 50 Hz. In the data itself given, what is the source current? What source current corresponds this one is the 25 amperes. 25 amperes. In the question itself, capacitance value is given. Capacitance value is given. Frequency value is known. Can you find out with respect to capacitive reactance? Capacitive reactance. What capacitive reactance formula is a XC equal to 1 by 2 pi FC. 1 by 2 pi FC. Frequency is 50 and C value also known. Can you find respect to XC value? Respect to XC value. Karo ji calculations karo. Find out XC value. After finding XC value, can you find out the current in the capacitor? Can you find out current in the capacitor? Current in the capacitor, what do you write is for the source voltage by respect to capacitive reactance. Source voltage by respect to capacitive reactance. Source voltage how much here? 300. 300 by respect to XC. Give the answers. I gave hints. Give the answers for this one. Give the answers for the XC value. Find out XC value. Then I have to find out the IC current. Anybody answer IC value? IC answer. Reply. Check karo. IC is a 15. In this one, if you simplify this one, this IC equal to 15 amperes. Now this is a RC parallel circuit. RC parallel circuit. Here the total current is known, IC value is obtained. Can you find respect to IR value? Can you like this sir, this 25 equal root of IR square and the IC square. IR square and IC square. What is the IC value? IC is a 15. IC is a 15. By simplifying this one, can you find out IR value also? Simplified, find out IR value. Simplified, find out IR value. IR equal to 20 amperes. Very good. IR equal to 20 amperes. Now this IR is completed. IR is also completed. Now this IR is known, source voltage is known. Can you find respect to resistance value? From the case 1 result. From the case 1 result, can you find out respect to resistance value also? Can you find respect to resistance value? What is the resistance equal to this source voltage by respect to IR? Source voltage 300. What is the current of this one is the 20. Current is 20. What about resistance is the how much here? 15 ohms. Resistance is 15 ohms. 15. Very good, very good, very good, very good. Resistance is 15. Okay. Now come to case 2. Chalo, अब case 2 चलेंगे. Now correspond case 2, you gave one statement. The input current is remains same. You give the statement as a that input current is remains same. Input current remains same. But what about this supply voltage? How much here? Supply voltage become the 360. Supply voltage becomes 360. Supply voltage becomes the 360. Now in this example, what is frequency also? There is no modification of frequency. Frequency also 50 Hz. Regarding frequency, no information is given. That's why the frequency is same as the previous one. Frequency same as the previous one. Now current is remains same. Now again, can you find the new capacitive reactance? Let us name as XC dash. In this example here, every time resistance value is a constant. Every time respect to resistance value is a constant. Every time respect to this resistance value is a constant. Respect to resistance value is a constant. Again, can you apply same concept? Can you repeat the same procedure? Can you repeat the same procedure? Now what about this one? This resistance value same as the previous one. What resistance value how much here? 15. Can you find out the IR value first? What is IR equal to 360? 360 by R. What how much here? 24 amperes. Okay. Now can you find out respect to IC value now? Can you find respect to IC value? Now IC equal to, simply we can write this with a 25 square minus IR square. Now correspond case 2, we are finding the respect to IC value. Can you find out IC value? Can you find respect to IC value? Answers. Oh, in this one you have to find out frequency. Yes, yes, yes. Frequency you have to find out. Anybody IC value? Anybody IC value? IC answer? IC? 7 amperes. Okay. IC is a 7 amperes. Now correspond to IC, what is the expansion for this one? IC equal to what will it is V by XC. IC equal to what will it is V by XC. V by XC, what is the XC expansion? The 1 by omega C. 1 by omega C. 1 by omega C. Can you write this? Now in this example, what is the new current is how much here? 7 amperes. What is the new supply voltage? How much here? 360. What is the omega expands the 2 pi f? In the data itself, capacitance value was given. Now capacitance value was given. Capacitance value how much here? 159.23. 23 microfarad. Simplified. By simplifying this one, can you find out frequency? Can you find out new frequency? Can you find a new frequency? I gave all the hints. Now give the answers. Check karo. Many students are saying 19.4 Hz. Is it correct? 19.4 Hz. Check karo. Is it correct? 19.4. Very good, very good, very good, very good, very good. Okay. This one you have to solve carefully. This is a multiple select question. In this one, more than one option is present. You have to conclude very carefully. Note this question. This is a MSQ question. This is a MSQ question. Okay. Now let us see how can you solve this one. Okay, let's check it out. Now correspond given data, what is the statement given as a resistance in series with the coil? Meaning of coil is a inductor and corresponding internal resistance. Combination of the inductor and internal resistance, for that one we use word as a coil, Here this resistance, let us name this with the R. The coil resistance, let us name as R coil, and corresponding inductance value. In the question is asking the resistance values, coil inductance also is asking the inductance of the coil, Meaning of coil is a including inductor internal resistance. Combination of the inductance and internal resistance, combination of these two, we use word as a coil. Idhar dekhiye. For this particular example, what is source voltage? How much here? 250. Source voltage is 250. 250. What about frequency is 60. And in the question you gave one statement, what a current in the network, is 5 amperes. And voltage resistance is 125. Now for this one, what is the voltage resistance is 125. Now what about this one, voltage across the coil, is 200. Now across this coil is 200. Now come to the options. Now this is a multiple select question. Every option you have to verify. Relatively when compared to previous questions, it will take a little more time. For every option you have to verify. Now what are the requirement? The total resistance, coil resistance, inductance, as well as the power dissipation. Chalo, check karenge. Now for this example, first can you find out this resistance value? Can you find this R value here? How do you get this one? This voltage is known, resistance is known. This voltage is known, current is known. From these two, can you find out respective resistance value? 125. What are the given current is how much here? 5 amperes. Given current is 5 amperes. If you simplify this one, what resistance how much here? 25 ohms. This external resistance is 25 ohms. Come to the second part. Now second part is now for this entire coil, this voltage is known and this current is also known. Can you find out the impedance of the coil? Can you find out this impedance of the respective coil? Now correspond this one. If you find out the impedance of the coil, what do you write this as a voltage correspond to coil by respect to current. In this example, voltage given how much here? 200. What about the current of this one is a 5. If you simplify this one, what about the value of this one is a 40. What is the value of this one is 40. Now correspond to this impedance, can you do the expansion? Can you do the expansion here? Now we can write this as a Z equal to root of can we write this here? Root of r square and the x square. Now again, if you rearrange this equation, can we write this here? We can also write this as a XL. Now let us name this as the equation 1. Now we got the inductive reactance of the coil in terms of resistance. Okay. Come to the next step. Next step is let us find out the total equivalent impedance. The total equivalent impedance we can write this as source voltage by corresponding current. Source voltage given as how much here? 250. Now what about the corresponding current is 5. Then what is the equivalent impedance? How much here? 50. Equivalent impedance is 50. Again, for this equivalent impedance, how do we write the expansion for this measure? We can write this as root of R plus resistance of the coil whole square equal to 50. Now for this example here, now what is the total real value is R plus R coil and corresponding inductive reactance. Now I gave all the hints. In this expression, this R value is known. What is the R value? How much here? 25 ohms. And this inductive reactance value is known in terms of the resistance of the coil. Can you substitute here? Substitute the R value and this equation 1 in this equation 2. Let us name this as equation 2. Substitute the resistance equal to 25 and substitute this equation 1. Substitute the equation 2. Do it, simplify this one. Find out the resistance of the coil. I gave all the hints. Do it. Substitute the R value and this equation 2. Can you find out resistance of the coil? Check karo ji. Anybody answers? Substitute the equation 1 and as well as that R equal to 25 ohms. Substitute that equation 2. Equation 1 को and R equal to 25 ohms को दोनों को substitute करो equation 2 में. Simplify करके give the answers. What resistance of the coil? Answers. Reply आना है answers. Check karo, somebody is saying 5.5, is it correct? 5.5 ohms. Check karo, is it correct? 5.5 ohms. Very good. 5.5. Now after that one question में क्या पूछ रहे हैं इधर? What is the one of the requirement resistance of the coil? 5.5. That means B is the one of the correct answer. That is the completed. In the last option, what is asking? The total resistance. Now here the total resistance means, shall I write this here? In this example, R equivalent. This R equivalent is a R plus resistance of the coil. Now that is the total resistance. Regarding R, we already concluded. R value how much here? 25. Resistance of the coil also concluded. What is the answer for that one is a 5.5. Now 30.5. Total resistance 30.5. In the D option, what is given as a 30.5? That means D is also one of the correct option. Come to first option. In the first option, what you give this was the power dissipation, power absorbed by the coil. Now that means in this example, simply we have to find out the power dissipation. Power dissipation correspond to coil. Power dissipation correspond to coil. Now power dissipation, what do you write formula is simply write is I square. Shall I write this here? Power correspond to coil. In the data itself, current was given. Current how much here? What the given current is a 5 amperes. The given current is a 5 amperes. Current is a 5 amperes. What the resistance just now we got is a 5.5. Can you conclude? Anybody power? Anybody power? Power? Can you conclude the power? Anybody? Power 137.5. 137.5 watts. Now what is the first option given as a 137.5? That means A is also correct option. A is the correct, B is the correct, D is the correct. But one more thing we have to verify the inductance. One more thing we have to verify the inductance. Now to conclude the inductance, can you use this equation 1? To verify the inductance, can you use equation 1? I think in the data itself, frequency was given. What is frequency? How much here? 60 Hz. Frequency 60 Hz. Now correspond this equation 1. What is the expansion for this measure? Can you write this the 2 pi FL? For this, what is the expansion of 2 pi FL? Now resistance of the coil. Regarding resistance of the coil, we already concluded. How much we got then? 5.5. Check karo ji. Simplify karo. In the question itself, frequency was given. What is frequency? How much there? 60. Frequency 60. Check it out. Can you find out the respective inductance value? Anybody answers? Can you find out inductance value? 0.105. Check karo. Many students are saying, I am writing your answers only 0.105. 0.105. But in our options, if you observe carefully, in our options, in the C option, what is inductance given as a 10 Henry? That means that is incorrect. That means what are the correct options here? A, B, D are the correct options. Now in this example, except C, remaining all options are the correct. Except C option, remaining all options are the correct. Very good. Very good. Okay. Can you write the next one? Especially in this resonance topic, if you remember the formulas, we can save the time in the exam. Otherwise, we have to do the derivations. Doing derivation means it takes very much time. That's why try to remember the formulas correspond to series resonance and parallel resonance. Try to write all the formulas in a separate sheet. In the one side series resonance, other side parallel resonance. Do the comparison. Because very much similarities are in the series resonance and parallel resonance formulas. In our entire network analysis, especially for the resonance topic and two-port network, we have to remember the more number of relations. Shuklaji, in the options, he gave this one as watts. That means only active power is sufficient. Energy is not required. Shuklaji. Now come to the next one. Now correspond this example. Now correspond to this particular example here. Now resonant frequency is given. What resonant frequency? How much here? 5 Hz. Now whatever the bandwidth is also given. What the bandwidth is also known. Now what is one of the requirement is the quality factor. One requirement quality factor. Other requirement is the inductance. Now for quality factor, one of the formula, can we write this? This F naught by bandwidth. One of the formula for this is the F naught by bandwidth. Now directly can conclude what the resonant frequency is a 5. whatever this bandwidth is a 2. What is quality factor equal to 2.5. If you remember the formulas, we can easily conclude the answers. What is the one more requirement? Inductance. Let us see how can you conclude the inductance. Let us see how can you conclude the inductance. Now correspond this example. In the data itself, power dissipation is given. Power 500 watts is given. At what condition? Resonance condition. In the question they mentioned the power dissipation. Correspond which one here? Resonance condition. Now under resonance condition, shall I release Z equal to only R? Correspond resonance condition. What is Z equal to only R? Imaginary part of the impedance equal to 0. Imaginary part of impedance equal to 0. Then to conclude the power dissipation, can we write this here? Simply we can reduce the V square by R. V square by R. Because in the data itself source voltage was given. What is source voltage? How much here? 200 volts. At resonance condition, imaginary part equal to 0. Only real part is the present. Only real part is the present. Can you substitute respective values? What the power is the 500. What about this voltage? Voltage is the 200. By simplifying this one, first can you find resistance value? Simplified, first find out resistance value. Check karo ji. First find out resistance value. Anybody answer? Resistance value how much here? 80. Resistance value is 80. Resistance value is 80. What is the bandwidth formula is F2 minus F1. In terms of circuit elements, what is the formula is R by 2 pi L. You have to focus on units also carefully. In the data, they may give units as radians per second. They may give in terms of H. If radians per second is given, what is the bandwidth formula is simply R by L. R by L. Concentrate on the units carefully for this one. Now for this particular example, bandwidth how much here? 2 kHz. Bandwidth is 2 kHz. Now what is the resistance value? But resistance is 80. 2 pi FL. By simplifying this one, can you find out the inductance value? Simplify karo. By simplifying this one, you get the inductance. Simplified, you get the inductance value. Check it out, 6.36. Check out, many students are saying 6.36. Is it Henry or millihenry? Give the reply. 6.36. Henry or millihenry? Millihenry. 6.36 millihenry. 6.36 millihenry. Okay, millihenry. Okay, I am writing your answers only. Okay, very good. Write this question. Now what is the requirement? C value at what condition here? Resonance condition. What requirement? C value at what condition here? Resonance condition. In the question itself they mentioned unity power factor. In the question itself they mentioned unity power factor. Unity power factor corresponds to resonance condition. Now can you divide this impedance into two parts? Now this the corresponding inductive reactance and respect to resistance value. Inductive reactance respect to resistance value. Now can you expand this one here? If you expand this one, corresponding reactance, what do you write this way? 30 sin 40 degrees. Simply write is Z sin theta. What is resistance value? How do you write this way? 30 cos 40. That means entire impedance we separate into the two parts. He is asking the C value at unity power factor. Unity power factor means resonance condition. Now correspond to parallel circuit for any combination circuit under resonance condition, BL should be equal to BC. Under resonance condition, what we write, the BL should be equal to BC. In the branch 2 combination of elements are present. Whenever the combination of elements are present, what is the BL formula is the XL by R square and the XL square. Now what about the branch 2? Branch 2 only capacitor is present. If only capacitor is present, what is the expansion for this? 1 by XC. Can you substitute the respective values? I give all the hints. In place of XL, what you can write, the 30 sin 40. In place of R, we can write this with 30 cos 40. What are the XC? XC equal, what are the XC replace 1 by omega C. If you expand this one, can we write this here? We can write this as 2 pi FC. XC equal 1 by omega C. By rearrange this one, we can write this. In the question itself, frequency also given. What is frequency? How much here? 50 Hz. Frequency is 50 Hz. Now I give all the hints. Substitute the frequency equal 50 Hz. Substitute frequency 50 Hz. Simplify it, find out C value. Find the C value. What is the answer? 68.2 microfarad. Milli or micro? Checked out. Somebody is saying 68.2. What is 68.2? Microfarad, millifarad. Somebody asking what is the BL and BC? Inductive susceptance. Somebody asking what is the meaning of BL, BC? आप पढ़े होंगे parallel circuits में. Inductive susceptance. BC is the capacitive susceptance. Okay, Lipe. Inductive susceptance, capacitive susceptance. Microfarad. Okay. At the next question. Find short circuit current with respect to A and B. Short circuit current with respect to A and B. Now observe here. Now we can easily conclude. Now corresponds example, this AB terminals are short circuited. Whenever these AB terminals are short circuited, if any current is coming, current always goes to low resistance path. If any current is coming, entire current bypass to short circuit. If entire current bypass short circuit, what the current of this branch equal to 0. If current equal 0, whatever dependent source value also 0. Now dependent source value 0 means how do you indicate this as a short circuit? Now this voltage source means how do you indicate this by the short circuit? That means in this example that voltage source position we can indicate as a short circuit. Voltage source position we can indicate as a short circuit. Voltage source position we can indicate as a short circuit. Now what is the requirement of the ISC? What is the requirement of the ISC? What is source current given as a 10 at angle 30 degrees? 10 at angle 30. Current always goes to low resistance path. Current always goes to low resistance path. In this example, this entire current bypasses to short circuit. Now capacitor, resistor, inductor, entire current bypasses to short circuit. That means this entire source current go to short circuit. Then what is ISC equal to? 10 at angle 30 degrees. 10 at angle 30 degrees. 10 at angle 30 degrees. Okay. चलिए write this question. Okay, very good. For this particular example, we have to find out ZL value such that maximum power for the circuit, maximum power. That means we have to use our maximum power transfer theorem. Now correspond this maximum power transfer theorem. First we have to find out the Z Thevenin's for this one. First we have to find out the respective Z Thevenin's. To find out Z Thevenin's, what is the procedure is deactivate all the independent sources. The current source replaced by open circuit. Now with respect to load impedance, we have to find out the Z Thevenin's. Now in this example, what are the values here? 80. Now whatever this means J 100 minus J 40. Can you find respect to Z Thevenin's value? Now here in this example, how this resistor inductor both are connected in the series. Now the series combination connected is in the parallel. Can you write this here? Minus J 40 80 plus J 100. By simplifying this one, can you find out respect to Z Thevenin's value? Simplified answers Z Thevenin's. Answers Z Thevenin's. Check करो, somebody is saying check करो जी Z Thevenin's. Okay, otherwise I'll give the answer, you can verify later. Simplify करो. Shall I give answers? Check करो, somebody is saying 12.8 minus J. Answer how much? 49.6. Check करो जी, is it correct? Z Thevenin's. Is it correct? Does anybody confirm? Now what is the requirement is what is the condition for maximum power? Condition for maximum power. Now correspond AC, whenever you are concluding condition for maximum power, read the given question carefully. In the question nothing is mentioned, simply mentioned as ZL is a variable. Whenever you mentioned as only ZL is a variable, by default, in the given example, you mentioned as a ZL is a variable. You mentioned as ZL is a variable. Now for that one, simply conclude the answer as a, what is the answer for this one? By default, we go for as a ZL equal to Z Thevenin's conjugate. Z Thevenin's conjugate. Okay. In our example, you mentioned ZL is a variable. In some of the questions, they make you like this. Now RL is a variable. RL is a variable. RL variable, simply they give this one as a, they won't give any data regarding XL. Only you give the RL only. If only RL variable is given, then what is the condition for maximum power? Now at that instant, write the ZL equal to mod of Z Thevenin's. Mod of Z Thevenin's. And in the questions, they make you like this. RL is a variable. RL is a variable and XL is a constant. XL constant. Now at that instant, simply conclude as a, the condition for maximum power is the RL equal to root of XL and the X Thevenin square. Correspond to AC maximum power transfer theorem. First identify cases carefully. If no information is given, by default conclude the answer like this. ZL equal to Z Thevenin's conjugate. Z equal to Z Thevenin's conjugate. And they make you like this. One more possibility is this RL, XL are the variable. RL, XL are the variable. But the load impedance angle is a constant. Then for that one, what is the condition for maximum power? Mod of ZL equal to mod of ZTH. Mod of ZL equal to mod of ZTH. Okay. Conclude the answers carefully. If no information given, by default conclude the answers correspond to case 1. Okay. ZL equal to Z Thevenin's conjugate. Okay. What is the requirement of the ZL? ZL means conjugate. Conjugate means you have to change the sign. Okay. Very good. Write this one. Read one more question. Yes, conjugate होगा मेगा अग्रवाल ZL equal to Z Thevenin's conjugate. Okay, चलो check करेंगे. In this particular example, this VA characteristics are given. VA characteristic correspond nonlinear load is given. VA characteristics. Now what is the requirement is the I value. Now for this particular example, this entire complex network can be replaced by single equivalent circuit. Single equivalent circuit means we are having the two approaches. You can go for Thevenin's theorem or the Norton's theorem. Any theorem you can apply. Now here I am going for the Thevenin's theorem. Then correspond Thevenin's theorem, you have to find out respect to V Thevenin's and as well as the R Thevenin's value. R Thevenin's value. Now whenever the dependent source is there, now we discussed the different methods. In the previous video, I discussed the different methods to find out the R Thevenin's value. In this example, we need both V Thevenin's value, R Thevenin's value. As per my previous video discussion, can use that method as a, in one of the methods I discussed it as a, for this complex network, assume one voltage source. Let us assume it is delivering current of the I. In my previous video, in the concepts, I discussed that one regarding Thevenin's theorem possibilities. This entire complex network replaced by Thevenin's equivalent circuit. Thevenin's equivalent circuit. Now V R Thevenin's, V Thevenin's, A and the B. Now what is the advantage of this method? Simultaneously you can get the both V Thevenin's value as well as the R Thevenin's value. Now if you rearrange this equation, this I equal to, we can write this V minus V Thevenin's by R Thevenin's. Now from this one, by rearrange this equation, we can write like this, V equal to V Thevenin's plus I R Thevenin's. That means, sir, by simplifying network, finally you have to obtain the general equation. Finally you obtain general equation. From this general equation, now you can conclude the respect to V Thevenin's value and R Thevenin's value. V Thevenin's value, R Thevenin's value. Chalo, let us apply this method for our network. Now corresponding example, this entire complex network is replaced by a single equivalent circuit. Now single equivalent circuit, here I am using the Thevenin's theorem. I am using Thevenin's theorem. Now correspond this Thevenin's theorem also. What the current is the 4 amperes. Vx. Can you replace this current source? Can you transform this? Can you apply source transformation here? If you apply source transformation, what about resistance of this one is a 50? No, 0.5 Vx, 0.5 Vx. Now correspond to arrow mark, give the positive sign and other one is a minus sign. We are converting this current source into equivalent voltage source. Current source into equivalent voltage source. Now we apply the source transformation to make the calculation simple. Okay. Chaliye. Now in this example, I am applying this. Let us find out both V Thevenin's value as well as the R Thevenin's value. For that one, what is the assumption? Across the AB terminals. Assume one voltage source. Okay. Now if you assume the voltage source, let us assume it delivering current of the I. Can you write the respective equations? If I take this point as a ground, in this example, what is the node voltage? Node voltage how much here? Vx. Voltage across this entire branch is the Vx. With respect to ground potential, what is the polarity at this point is a 4. What is the polarity at this point is a plus. If you write the KCL equation here, can you write the KCL equation? What is the 4 amperes is the incoming current. 4 amperes is incoming current. Now here we write this as this is a Vx by 20 outgoing current. Now here the plus similar polarities subtraction. Again the plus similar polarities subtraction minus V. But the corresponding resistance how much here? 50. We got the equation 1. But what is the requirement? We need the V equation in terms of I. But what is the additional term present here? Vx. Now for that one, can you write the one more equation? Wherever the current is entering, there is a positive and other one is a negative. Can you write the KVL equation for this one? Can write one KVL equation for this one? If you write the KVL equation for that one, now lower potential to higher potential voltage rise. Higher potential. Now by rearranging these two equations, can I write the V value in terms of I? Check karo ji. Rearrange these two equations. Check karo. Rearrange this equation 1 and equation 2. Finally, can you obtain this V value in terms of I? Do it. Check karo. Check karo. We get some constant values, I coefficient and some constant values obtained. Give the answers. Can you rearrange this equation? Check karo ji. check karo, somebody is saying 40 plus 60i. Getting now? Rearrange this equation. In this one, try to separate the Vx value. Try to separate the Vx value in terms of V and I. Now substitute that one here. From this equation to separate the Vx value in terms of I and V, substitute here. Simplify, you get like this. Can you compare this with standard formula? Can you compare the standard formula? What is standard formula is V equal to, previously we discussed it. Standard formula क्या है जी? V equal to V Thevenin's, R Thevenin's and I. Then what V Thevenin's is how much here? 40. Then what about this R Thevenin's is 60. Check करो. V Thevenin's is V Thevenin's is 40 and R Thevenin's is 60. Okay. Now V Thevenin's, R Thevenin's are completed. V Thevenin's, R Thevenin's are completed. Now come to given question again. Come to the given question again. Now correspond given question. Now this entire complex network replaced by a single equivalent circuit. Entire complex network replaced by a single equivalent circuit. It is connected to a non-linear load. In the data itself given, what is the voltage of non-linear load is the V. Corresponding current is I. Now from the calculation, what we got? V Thevenin's is a 40. V Thevenin's is 40. Whatever this R Thevenin's is a 60. R Thevenin's is 60. Can you write the respective KVL equation for this one? If I write the KVL equation for this one, what source voltage is 40, lower potential to higher potential voltage rise. Now current in this nonlinear resistor and this R Thevenin's both are the same. We can write this as 60I. Now whatever the plus V is equal to 0, Magar here in the question itself one relation is given. Can you substitute that relation in this expression? Minus 40, 60I. What is the V replaced by, what is the equivalent value is of 4I square minus 48I. Now finally for this, simplify this quadratic equation, find out I value. I gave all the hints. Check karo ji. I gave all the hints for this quadratic equation. Can you find the roots for this one? Akash, S2, very good. Okay. Okay, checked out. Many students are saying I equal 2 amperes. Check karo ji, I equal 2 amperes. Okay, I equal to, we consider only positive current. Negative sign we won't consider. Finally we consider only positive one. We consider only positive current. Okay. Now write this question. In this example, correspond this given example, in the data itself given, what is the initial current, how much here? 6 amperes. Initial current is 6 amperes. If you observe carefully, in this particular example, no independent source is given. No independent source is present. That means after operating switch also, after operating switch, what the action of inductor will be discharging only. Because no external sources are connected. In the question itself given some initial current is present for the inductor, discharging inductor. Now for discharging inductor, what is general equation? For discharging inductor, what is general equation? Exponential of minus RT by L. Exponential minus RT by L. Now what is I naught indicate the initial current? What is I naught indicate the initial current? In the data itself given initial current how much here? 6 amperes. Initial current is 6 amperes. Now can you eliminate the two options? Which are the incorrect options? C is incorrect, D is also incorrect. Two options are eliminated. Because in the data itself mentioned initial current equals 6 amperes. Come to this A and the B options. To conclude this A and B options, what is the other thing we have to find out the time constant. Can you find out respect to R value and L value? R value and L value. L value is the only one inductance. Inductance how much here? 6 Henry. For this R value, what you have to find out? R Thevenins. R Thevenins. That is the one approach. One approach to conclude the other options is simply find out the time constant of this network. Time constant R Thevenins. That is the one approach. On the other hand, you can apply Laplace. Choice is yours. You can follow any method, whichever method convenient for you. One approach is to find out the time constant. That is the one approach. Now other approach is simply apply the Laplace. Any method you can follow. Okay, just I am writing steps correspond Laplace. Now here the 10 ohms. Inductor have the initial value. Inductor have the initial value. Now whenever the inductor have the initial value, now elements are connected series. I am indicating initial value as a voltage source. In the data itself given arrow mark. Corresponding arrow mark give the positive sign and other one is the negative sign. Again still here to make calculation simple. To make calculation simple. Can you transform this current source into equivalent voltage source? We are developing equivalent circuit for t greater than 0. T greater than 0. Can you transform this current source into equivalent voltage source? Transform this current source into equivalent voltage source. If you transform this into equivalent voltage source, what do you get the voltage source is 20I. Greater than 20I of S. Now arrow mark indicated downwards. Arrow mark indicated downwards. Now what about resistance of this is 40. Resistance is 40. Now inductance value given as how much here? 6. You can write as 6s. Inductance 6. What is the initial current is also how much here? 6. Now 6 and 6. What do you write is 36. What do you write is 36. Now in the data itself given I of S. I of S. Any method you can follow, but I suggest the time constant method. I suggest the time constant method. But to get the idea about this one, I am using the Laplace steps also. Now here I of S equal to here the plus minus means addition. Corresponds example plus minus means addition. 36 plus 20I. Then what about this one is a 6s and 10 ohms. What is the one more resistance is the 40 ohms. Can you simplify this I of S? Can you simplify the I of S? Simplify the I of S, apply the inverse Laplace. Simplify I of S, apply the inverse Laplace. Okay. But dear students, with respect to exam point of view, don't prefer this method. Try to prefer the first method, time constant method. क्यों बोलते हो convert transformation and simplify the I of S and apply the inverse Laplace, it will take a very much time to get the solution. That's why in the many objective questions, with help of our classical method, we can easily conclude the answers. In the very few objective questions only, like if network has more number of energy storage elements, then only prefer the Laplace. Otherwise, my suggestion is go for the classical method only. Go for classical method only. Okay. Can you anybody answer? Simplify the I of S, apply the inverse Laplace. Anybody answer? Check karo. B is the correct option. Yes, B is the correct option. B is the correct option. Very good, very good, very good. Okay. But I prefer the time constant method. Find out the time constant. That is the easy approach when compared to this one. Okay. Now come to this one. Okay, note on this question. Okay. Okay, later you can copy. Then I will explain the method. Later you also can copy. Later you can pause the video and you can copy the question. Just I will explain. इधर देखिए. Now corresponds example. What is the requirement of the current response in the inductor? Current response in inductor. In the given example, initially the switch was current position A. Position A. Now first let us find out respect to initial value. Let us find respect to initial value at 0 minus. Now what is the meaning of 0 minus is a steady state condition before operating the switch. Steady state condition before operating the switch. Now position A. Under steady state condition, how this capacitor behaves as a open circuit. Under steady state condition, how the capacitor behaves as a open circuit. Capacitor behaves as a open circuit. Now what about this inductor behaves as a short circuit. Inductor behaves short circuit. It is connected to position A. Position A. Now R1, whatever this is the RV1. What is the requirement? Initial current corresponding inductor. What is the requirement is the initial current corresponding inductor. What is the requirement is the initial current corresponding inductor. देखिए IL of 0 minus. IL of 0 minus. In this example, source voltage how much here? V1. Source voltage V1. But respect to resistance is the R. V1 by R. V1 by R. Initial current is completed. Initial current is completed. Now observe carefully. Now correspond to given example. At t equal to 0 seconds, switch the transfer to position B. Correspond given example. At t equal to 0 seconds, the switch is transferred to position B. When a switch is transferred to position B, capacitor and inductor and corresponding inductor, some initial current is present. Some initial current is present. Some initial current is present. Okay. Whenever the switch is transferred to position B, no external source is there. No external source is there. That means what is the initial current? How much you got here? V by R. V by R. Again, can you observe the options? Observe the options. But the initial current given as a V by R plus R1. It given as a V. It given as a V1 by R. It is also V1 by R. That means A option is incorrect. C option also incorrect. This A option is incorrect. C option also incorrect. Because what is the initial current? How much you are writing here? V1 by R. Okay. Chaliye. Now come to B and D options. In this B and D options, if you observe carefully, in this example, inductor has some finite energy. What will happen? Inductor start the discharging, capacitor start the charging. After few seconds, capacitor start the discharging. Again, inductor start the discharging. The capacitor start discharging, thereby inductor start the charging. Likewise, continuous energy transformation done between the inductor capacitor. Continuous energy transformation is done. That means which response is obtained? Oscillatory response. Now for this oscillatory response, can you find with respect to omega value? Omega general formula क्या है? 1 by root LC. Omega general formula क्या है? 1 by root LC. Here the only one inductor and only one capacitor is present. Only one inductor, only one capacitor is present. Now omega equal 1 by root LC. Check करो. Which option supporting here? Here the omega equal 1 by root LC. Here the 1 by 2 root LC. Now again can you eliminate this option also? Dear students, if you apply the elimination process, we can save the time in the exam. Especially in the two-port network and transient chapters, if you go for the elimination process, we can save the time. If our target is the only answer, then what is the appropriate answer for this? B. Okay? This is one method. Try to verify other method later. Transform this one to S domain. Check karo ji. Transform this one to S domain. With help of the Laplace, check it out. You'll get this answer. If network has the more number of energy storage elements, for verification answer, prefer the Laplace. Okay? Read this question. MD Shohel, magnetic circuit part is not important for the electronic students. For electronic students, magnetic circuit part is not important with respect gate point of view. Okay, the magnetic circuit part important only for electrical students. Okay. What is the requirement is the input impedance. Here the T is given. What is the meaning of T is transmission parameters. ABCD parameters are given. In the given example, ABCD parameters are given. Now, what is the requirement is the input impedance. What is the requirement is input impedance. Now, with respect to input terminals, what is the voltage this one? How much here? V1. What is the current of this one is I1. Voltage V1 and current is I1. Input impedance is equal to what do you write this way? I1 by V1. I1 by V1. In the question, which parameters are given here? Transmission line parameters. That means ABCD parameters are given. Try to remember all the equations correspond to Z parameters, Y parameters, H parameters, ABCD parameters. What are the standard equations for this one? Now we write this one CV2 minus DI2. What about this V1 equal to, we write this one the AV2 minus BI2. Minus BI2. Okay. Now come to output terminals. Now with respect to two-port network, what is the output voltage? How much here? V2. But the current should be inverse. With respect to two-port network, always both current should be the inverse. Both currents should be inverse. Now correspond this output terminals V2 equal to, when the current enters negative terminal, sign for the current is taken as a negative. When the current enters negative terminal, sign for the current is taken negative. We can write this way V2 equal to minus 3I2. V2 equal to minus 3I2. When the current enters negative terminal, sign for the current is taken as negative. Sign for current is taken negative. Now I give all the hints. Can you substitute the respective values in this one? Input impedance. देखिए C value is how much? 3. C value is 3. What is V2 replaced by equivalent value is a minus 3I2. What is the D value given as how much here? 8. What about this A value is a 2. A value is a 2. Now what about this one is a B. Now corresponds example, what about B equal to 4? B equal to 4. 4I2. I gave all the hints. Can you simplify it? I gave all the hints. Can you simplify it? Y input. How much? I gave all the hints. Input. Check it out. Check it out. 1.7. 1.7. 1.7. Very good, very good, very good, very good. Very good. 1.7. Okay. Write this one. Transmission parameters. Okay. Now what is the requirement is the ABCD parameters. To find out this ABCD parameters, we can go for different approaches. What are the standard equations for this one is the V1 equal to AV2 minus BI2. What about this I1 equal to CV2 minus DI2. Minus DI2. Okay. One approach for to find out this ABCD parameters is the, if you want to find out this A and C, this make this I2 equal 0. I2 means output is the open circuited. And to find other two parameters B and D, this V2 should be equal to 0. V2 0 means output is a short circuit. Output is short circuit. That is the one approach. On other hand, this other approach is a, now for given network, try to write the KVL and KCL equations. For given network, write the KVL KCL equations, then rearrange it according to our stand equations. Rearrange it according to stand equations. Now I am going for second method. And one more thing. Now for this particular example, here options also given. Note on options also. Especially in two-port network, write the options also. Write the options also, I will explain. Shankar, mutual inductance concept, dot convention, all these are with respect gate point of view for electronic students not important. Okay. Shukla, thodi der rukiye ji, thodi der rukiye. This is the last problem. This one I will close this one, don't worry. Okay, options also given. Now what is the requirement is the ABCD parameters. What is the requirement is the this ABCD parameter, that is the requirement. Okay, chalo, let's check it out. Let's write the respect to this KVL and KCL equations according to this given figure. According to this given figure. Now observe here. Now for this particular example, with respect to input, voltage of this means how much here? V1. With respect to input, what is the voltage of V1? What is the input current? What is the input current of this means I1? Input current is I1. Now if you apply the KCL at this point, corresponds example, if you apply the KCL at this point, whatever this is the outgoing current, now this is the incoming current. Now this is the outgoing current, incoming current. Now remaining current of this one, can you let this here, this I1 minus 0.25 V2. Simply apply KCL at this point, incoming current, outgoing current. Again, can you apply KCL at this point? Can you apply KCL at this point? If you apply KCL at this point, now this is the incoming current, whatever, this is also incoming current. Corresponds example, it is the incoming current, it is also incoming current. Now can you write this one, current of this one, what do you write this one as a? Corresponds example, we write this as I1 plus I2. I1 plus I2 minus 0.25 V2. Minus 0.25 V2. Okay. Now for this entire network, now we got the current of each branch. Now let's write the respect to this KVL equations. Let's write the respect to KVL equations. Can I write the KVL equation correspond this one? Can I write the KVL equation correspond this one? If I write the KVL equation for this one, corresponds example, if I write the KVL equation, here the lower potential to higher potential voltage rise V1. Now in this 5 ohm resistor, how much current circulating is the I1? 5 I1. Now whatever this means the lower potential to higher potential voltage rise. What do you write is 2V1 plus. Now correspond to 4 ohm resistor. In the 4 ohm resistor, what current circulating is the I1 plus I2 minus 0.25 V2. Minus 0.25 V2. Now this is the one equation. We developed the KVL equation correspond dotted lines. Now we got the equation 1. Now second equation, can you write this? Corresponds example, the second equation, can you write like this direction? If you write here, whatever this write is a lower potential to higher potential voltage rise. Now V2 equal to what is the resistance of this one? How much here? 4. Resistance of 4. What the current is the I1 plus I2. 0.25 V2. I gave the two equations. Can you rearrange it? By rearrange this one, can you convert this one as standard equation of ABCD parameters? Can you convert it as standard equation of ABCD parameters? I give the two equations, rearrange it, modify that one as standard equation of the ABCD parameters. Getting now? Okay. Suppose if you come to equation 2. Now corresponding to equation 2, if you simplify, what do you reduce with V2 equal to, what do you reduce with 4I1? Now 4I2. Now whatever this one is a V2. From this one, can you separate the I1 expression? Check it out. Can you like this? From this equation 2, by expand this one, can you separate like this? Now, can you compare this to standard equation? Can you compare the standard equation? Standard equation is the I1 equal to CV2 minus DI2. Now, two answers are completed, C and the D. Okay. After finding two answers, now focus on options. Don't go for the remaining calculations, go for the options. In this example, how much we got here? C equal to 1 by 2, but D equal to 1, I2 quotient minus D, I2 quotient minus 1. C equal to 1 by 2, D equal to 1. Which option supporting? Now it is incorrect. Whatever, this is also incorrect. 1 by 2, 1. What is the correct option? A. That means without going for the further calculations, this A and the B, only with help of the C and D itself, we can calculate the answer. That's why whenever they ask all the four parameters, focus on the options. According to options, by applying elimination process, we can save the time in the exam. Okay. Okay, dear students, with this one I am closing the session and wish you all the best.